Now let's talk about standard form and scientific notation with negative exponents. So now we've talked about standard form, we've talked about scientific notation, and we've talked about negative exponents. Remember, negative exponents means that we have a really small number. For standard form and scientific notation, up to this point, we've looked at only really big numbers, but remember, we had said that scientific notation, we can write really small numbers in this shortening form as well. So let's try this with an example. We have 3.1 times 10 to the negative fourth power. All right, so this is still in scientific notation because we have one digit before our decimal. Then there's another non-zero number after that, times a base of 10 raised to some exponent. In this case, our exponent is negative. We have negative 4. So now for this, we're still going to take the same approach, except this time, we know our number is going to get smaller. So it's like dividing by 10 each time. So we'll start with our 3.1, but I'm going to move, instead of moving my decimal to the right when we're converting it to standard form, we're going to move it to the left. And I'm going to move it still 4 times, but this time to the left. So I move it 1, 2, 3, and 4. 4 spots. And now, since I moved my decimal there, and I need to show those places, those spots that I moved over that decimal, I got to write in my zeros. So I draw in 3 because I moved the first decimal over to before our 3, then for the remaining ones. Once I do that, remember that's 4 times because of my exponent, I get 0.00031. That's my standard form. So I'm just taking my decimal, moving it over to the left this time because I have a negative exponent. And the way to remember this right and this left, well, you move it right because your number is getting bigger when you have a positive exponent. But you move it left because your number is getting smaller because you have a negative exponent. So we get some decimal 0.00031 in standard form for this one. Let's try this with another example. We have 0.000000527. So that is a really small number. You can already see that scientific notation is going to make this way easier to write because that's a lot of zeros to keep track of. So we're going to take a look at this. And this time, scientific notation goes in the opposite direction as when we had a positive exponent. This one's going to have a negative exponent, so we're going to move it to the right because we're changing it to scientific notation. So now I'm it's like making my number bigger, so I have to account for that by making my exponent smaller, right? Negative exponents are small. So I'm moving that decimal over, again, to right after that 5 because it's a non-zero number. It's my first non-zero number. I move it 1, 2, 3, 4, 5, 6, and 7. 7 spots over to the right. But because I had this really small number, I have to keep my negative exponent. So I have 5.27 times 10 to the negative 7th. Remember, I had 7 spots, I moved it over. That's where my exponent's coming from. It's negative because I have a really small number. There's my 5.27 times 10 to the negative 7th, and that's my scientific notation. So there you have it, standard form and scientific notation with negative exponents. We use it for really small numbers.